Hi, good morning, everyone. Thanks for coming out. Apologies for the technical hiccup there. My name's Alan Day. I'm a developer advocate within developer relations in Google Cloud. The specific area I focus on is data and analytics. So that would be storage, BigQuery, data flow, PubSub, big data, etc. There are two verticals I focus in. One of them is life sciences, specifically genome sequencing for medical and agricultural applications. And you can see I blog about some things related to that. If you follow me on either Twitter or Medium, the username is here. Since I'm based in Singapore, I also decided to start working on some blockchain technologies. Singapore is a major global hub for this particular subsector of financial innovation, fintech. That's how I started working with Evgeny on the Ethereum ETL project. So he gives you a good basis for how we are loading the data into cloud and why it was an important thing to do. We give a couple of very brief queries showing that there are certain types of analyses that can be done once you stage the data into a data warehouse environment like BigQuery that aren't possible by interacting with the blockchain directly. I'm going to get deeper into that and show you the results of some analysis using some of the other analytics and data science functionality that's built into Google Cloud and Kaggle. Okay, so let's get into that. First, I'd like to start by telling you that this is work that I started at the beginning of the year, and the first publication of a blockchain data set came out in February. I started working on it roughly in December of last year. If you just do a search, we're now ranking very well on Google.com itself, the search engine. There's no special friendship between cloud and Google.com and Google.com, but it's recognized that these articles are important. So yeah, if you search for the string Google Bitcoin, you'll find that there's an article on the first page that's a blog post I wrote. And then in August, just about 6 weeks ago, Evgeny and I published another one. If you search for Google Ethereum, you'll find that. And I'll pull up the second of these blog posts in a moment to show you roughly what the contents look like. Okay. I can. All right. Do this. Yes. I'm not sure it's okay. Okay, so you can see this is on Google Cloud blog. Take a moment to load. I just want to show you that there's some figures in here. Oh, it's very small. So you can see that we're able to look, for example, at a time series. So this is since the beginning of 2018 to August or so. We can look at the amount of activity on the blockchain. It's interesting to point out, and I'm glad Evgeny raised this, is that there was some dramatic drop from 2017 into roughly February or March of 2018, where the amount of this cryptocurrency that's been moving around on the blockchain has dropped dramatically. And I'm going to get further into some analysis of this and what happens there in a moment. There's other stuff that it's not time series though. So for example, actually this is a good one. We can look for what the most popular contracts are on the blockchain by number of transactions. And CryptoKitties is the most commonly played game on this chain, and one of the more common, let's see, given that I'm in Thailand, I wrote about this. One of the more commonly exchanged tokens on the Ethereum chain is for Umisego. As many of you may be aware, this is a company that's based here in Thailand. You can see some interesting features of the number of transfers happening for this particular token on chain. Notice that the yellow and red and blue lines are in general very moving together. They're highly correlated, but there's some interesting feature happening roughly in late September of 2017. And this corresponds to something called an airdrop. So it's when Umisego actually gave away many tokens to users on the network to incentivize and encourage them to participate in the project. It's sort of like a marketing effort, basically. They're giving tokens away. That's a time series. Back to the CryptoKitties, let's look at this one though. So this is a chart that I did where I was looking at some aspect of the game where this game is composed of some digital collectibles that can be, and each one is representing a cat, like the animal meow, the real cat, right? They can be bred to make kittens, and so because all of this is happening on the blockchain, we can see the entire family tree of all cats that have ever been bred, the mother and the father, to make babies, and then we can look at the relationship between all of the parents and all of the children in a directed graph like this. So I'm showing here each of these circles is representing a cat, and then the color is representing a particular player of the game. So I've assigned colors to some of the more active players who are making more cats. And then the lines in between the circles correspond to a relationship between individuals. So it would be a parent-offspring relationship. The cats that are having more descendants, so they may have a lot of children, or their children may have many children, or the children's children may have many children, and so on, recursively, those particular cats get a larger circle than others. So you can see that not all of them are equally desirable. So that the cats who are having some more desirable traits by the owners will get a larger circle. And because, I want to point out, because all of this is on the blockchain, we have the information about the genetics of the cat. There's some modeling of the DNA, or how does the breeding take place, and how do the cats look. This allows us to actually build something like a predictive model of whether a cat, when bred, is likely to produce valuable offspring. So this has a lot of implications in the future for when we will have DNA for all cattle and pigs and chickens and rice and everything else that humans are cultivating as part of agriculture. And given my background, again, is coming from study of genetics, this is particularly interesting for me because we can begin to model out a real-world use case affecting agriculture, food security, and supply chain in a very small game-like context on the blockchain. So that's why I did this one. I think it's very interesting. Let's see what else we have. This is another graph visualization showing funds moving, the Umisego tokens again, moving on chain. And we can see that there is some relationship between different addresses. So it's not as if any one address on the blockchain transmits tokens at random to any other address. There's actually some organization to it, and that's why you're seeing there's a non-uniform structure here. In particular, many actors on chain prefer to send tokens to exchanges or withdraw tokens from exchanges. So the purpose of this is so that they can do trading of assets. I think that's the majority of this one. So yes, we did this with Ethereum detail. This data set is fully available on Kaggle, if you'd like to look at it there, for those of you who are interested in doing data analysis. The data set's here. So I'm going to jump back to my deck now and tell you more about what's really happening here. So I just gave you a bunch of details. The general theme, though, looks something like this. So we took Ethereum, right, just to summarize. We loaded it into BigQuery using an ETL process. And then once things were in BigQuery, we could do some interesting analyses, which I've labeled as enrich here. It's an enrichment process where we're analyzing the data. That analysis produces some derivative data. So for example, I now have the pedigree of all of the CryptoKitties. Or I now know that there was some interesting event in the Onisebo time series that looks like it corresponds to an airdrop. Okay, so those data that I produced were produced using some queries against the BigQuery data set, right? And they could conceivably be, the results could conceivably stored back in another table. And I actually did some of this for my own internal analysis. Notice that we can also swap out Ethereum for other blockchains. So the same thing holds true for Bitcoin. I did some analysis like this on Bitcoin. I don't have time to show it to you today, but you could load any data set in like this. I'm going to now show you some more figures going into that time segment where there was a lot of trading activity going on. Now, I'll point out here that everything that I'm going to show you in this particular, this is a Google Doc, just a regular doc, right? But what I also have, if you're not familiar with Google Colab, this is it's a data scientist's tool. So Colab is it's a Google Doc, but behind it is a Python kernel. So this is using a technology called Jupyter, or IPython Notebook, for those of you who've been familiar with it for a while. And you can see that there is a way to connect to a backend kernel here to actually execute code. So I can evaluate this Python script that could, for example, generate this figure inside the document. Now, I can also, because I have text here, I can also do comments, and I can share the document by editing it in Markdown here, just like you would do with any other Google Doc. So it's a way that you can get the nice collaborative functionality of standard Office docs and G Suite workflows being brought into a data science environment so that analysts can work together collaboratively on data sets. And so you can see in this particular document, what we did is we connected it to BigQuery, brought some of the data into a Python environment, and then started analyzing it. I don't have time to go into all of the details of the analysis, but I'm going to show you a few interesting highlights. And I'll also point out that this document is going to be made publicly available. So I'm preparing a blog post right now. That's what the Google Doc was. And it's going to link to this notebook. So anybody who wants to take my code and reproduce the analysis is totally free to do so. So where did I start? I'm just kind of in the middle of the document here. Okay, let's start. All right, so this is, let me walk you through what these plots are coming. What you see here is many plots that have the same data. So there's a total of 8 of these plots. On the x-axis, I'm showing you the number of days of operation of the Ethereum network. So it's been running for a few years now, going from 0 up to something like 1,200 days, so 3.5 years. Each of these black lines on the plot corresponds to an address on the blockchain that we believe is controlled by a bot. So there's some kind of automated process that has the private key for a public address and is able to perform transactions on the blockchain automatically. It's a daemon, a cron process. Okay, so the beginning of the line segment, they're all moving up to the right. So the point at which it intersects with the x-axis is the point at which we first observe the robot in time. Every time the robot is active for one additional day, we increment on the y-axis. So the y-axis is the cumulative number of days of operation. So bots that are running every day will be on the diagonal. Those that stop, they may run on diagonal and then stop for a little while, and then start running again, and stop and start running again. Or they may reduce in frequency. You can't really see it clearly, but there's some kind of the slope of some of these lines changes. It's sort of changing like this then logarithmically. That would be a decrease of activity in the plot. The reason I have 8 different panels here is that I've taken all factors in 24 hours and looking at activity within 24-hour windows. So these are ones that are operating every 1 hour, 2 hours, 3 hours, 4 hours, 6 hours, 8 hours, 12 hours, and every 24 hours. And you can see there's some pretty interesting substructure in here. Like, for example, this one, you can see that there's a whole bunch of bots that turned on around day 800. And they seem to be working together in some way, right? They turned on within 1 month of each other, certainly, probably within about 5 days of one another. And it looks like they're being coordinated and managed by some other process that's controlling each of the addresses. You can also see that there was for some reason, many of them were turned off at this point, and then recently a new cohort started. So it could have been that there's some process that was rebooted here. It corresponds to the one that started here at the beginning again. It's all speculation, but there's some additional analysis that can be done here that could turn up more information about what's really going on. We don't know because it's anonymous, right? So the purpose of this type of analysis is to try to look at these anonymous addresses on the blockchain and understand what's going on, because it's very hard to get any information about it. But if we use some machine learning techniques, we can begin to characterize the activities. So after seeing this, there's one particular class of address that looks really interesting. And it's an address type that is only active for 1 hour and then never used again. So it turns on, it sends money for about 1 hour, sends ether, and then turns on. It drains its bank account and then sends off. So we look more closely at these, and they have a very interesting pattern. This particular type of address shown here in, let's start with this one on the right. So this figure is showing what we've classified as the robot address, the bot addresses in yellow, from the beginning of time. Non-bot addresses, so this is basically human activity, is shown in blue. And then bot, what we're calling ephemeral activity. So these addresses that were only used 1 time and then never used again are being shown in red. And so you can see that there actually wasn't very much of this ephemeral activity until roughly March of 2017. And then it had a major peak proportionally, and then it actually dropped off in early 2018 to this is another way of visualizing the same thing, not proportionally, but by actual number of funds being transferred. And you can see that there's this big red spike that corresponds to these ephemeral addresses transferring ether on the blockchain. If we look deeper into this, here's an even better visualization. So this This is the number of transactions. So you can see basically this ephemeral network these ephemeral addresses were not doing anything, and then suddenly one day it turned on, and there began to be a whole bunch of activity of this particular strange one-time use address, and then roughly in March of 2018, it stopped. This is basically the same type of data showing proportionally that the ephemeral addresses were being used. And this activity of the ephemeral addresses, I've now overplotted in a black line the Ether to US dollar exchange rate. So how much is Ether worth in dollars? And you can see that before this thing turned on, the price was very low. And then the price actually started to rise. There was basically some kind of test here where this ephemeral botnet was turned on very briefly. We got a small price spike shortly after that. And if you just eyeball this, you can see that every time there's some big burst of activity of this set of ephemeral addresses, right after that, there's some major rise in price, and then after it turns off, you see that there's a major decrease in price. So, correlation does not imply causation, but it's very interesting to note that the activity of these ephemeral addresses is highly correlated and a leading indicator of changes in price of Ether in the exchange. This is the same thing denominated in dollars. So you can see there's actually about, I think that's about $30 billion of activity either being traded right at the peak here. So this is a not insignificant phenomenon I'm showing you here. Okay, so that's really all I've got to show about that. Again, all this analysis is open, including the labeling of addresses. That's important because of what I'm about to show you now. Many people who are working in this space are using proprietary information, and it's important for us to have public information available because this lowers the innovation barrier for more businesses to be created and more insights to be gotten out of the data. So this is the reason that I produced the Bitcoin and Ethereum datasets in the first place, and this enrichment process. What I'm now in the process of doing is releasing the code for how to do this, and I'm also releasing the quantitative and label data from those figures I was just showing you. That will also be going back into BigQuery. So all the results of my analysis, I'm also giving it away. The purpose of this is that I want to build something like a data exchange. Whether this data is stored in BigQuery or somewhere else, I think it's important for data scientists who are interested in analyzing blockchain data to have a way to work together. And so, just like I was doing some kind of enrichment process by querying some pool of public data and returning results back in, I'm envisioning a world soon where other parties who are also interested in doing this can query the public data, produce their own results, and then contribute it back into a public space. They can also use BigQuery's private tables. There's nothing preventing anyone from doing private activity on Google Cloud to profit from this. But this data model, this model of having a data exchange is a very powerful one. And so I'm encouraging anybody interested in doing this to follow my lead and start to collaborate and build on this public data set. If you're interested in doing so, collaborating in any way, as Evgeny mentioned, there's a blockchain ETL project. So this is the parent of Ethereum ETL, and it's where we're building the Apache Airflow, Composer DAG, and all the tools to get the data ingested. Not only covering Ethereum and Bitcoin and other blockchains fairly soon. There's another related project with ETL that has some of the Docker instances we're using to operate the payments. It's more of a DevOps type of project. We've also started a blockchain analytics group, so if you'd like to participate here in having some conversation, you're welcome to do that. We would would welcome anybody who wants to talk about ideas of what might be done with these data or report on problems with the data sets. And then as far as notebooks go, beyond the Colab notebook I was showing you, all of these data are available in Kaggle. So Kaggle was acquired by Google about a year ago. Google bought it about a year ago. It's the largest data science community. About 500,000 data scientists a month are active there. And so they're actively sharing notebooks and doing this kind of collaborative analysis that I'm showing you. And you could go and use this freely as well. Take my code, modify it, reproduce the results for yourself, verify everything I'm showing you is true. Find bugs, help me improve the quality of the classifiers, etc. Now, if you don't have time to actually write any code or make any contributions, but are just interested in following what's happening, feel free to find me on Medium. My name is Alan Day. You can also follow me on Twitter. It's the same thing, and I'll be regularly giving updates and blogging about what's happening with these public blockchain analytics projects. So that's all I have for you today. Thanks for listening. I hope you found this interesting. Thanks very much.